117. Inspection log open. Order stamped clearance. 1 grip safety. Not fully depressed. Trigger blocked. 1 report filed. Failure to fire. The log was sealed before the patrol chain shifts. In 1942 and 1943, British planners treated occupied Europe as a controlled system. German field forces depended on rail lines, telephone exchanges, local depots, and garrison routines that looked civilian on paper and military in practice. Britain's war had entered a stage where large operations were being prepared, but sabotage and intelligence work still had to run without provoking broad security crackdowns. The relevant front for certain equipment was not a trench line. It was the occupied rear area, where guards, patrols, and paperwork controlled movement. The Special Operations Executive operated under constraints that differed from conventional procurement. Teams were small and often isolated. Insertion was by parachute, coastal craft, or clandestine border routes. Equipment had to fit in limited containers, move through checkpoints, and remain storable in safe houses. Penalties for possession of weapons were severe, and an exposed arm could compromise an entire network. These constraints forced a search for devices that delivered a specific effect with minimal additional signature. The tactical problem was consistent across mission types. A team approaching a target might encounter a single guard whose removal had to be quick and contained. Standard pistols solved the problem but produced a report that carried through streets and buildings. Suppressors existed, but common self-loading pistol actions still produced slide noise and metallic impacts that were audible at close range. Revolvers avoided slide movement but vented gas at the cylinder gap and could not be suppressed effectively with simple muzzle devices. Knives and garrots avoided gunfire, but they required physical control and introduced struggle risk, which could generate noise and delay. German security methods in many occupied zones were becoming more procedural. Patrols were paired, alarm telephones were installed, perimeter lighting and flares were common around installations. Response after incidents often included curfews, document checks, and the detention of civilians. In that environment, the requirement was not absolute silence. It was reduction of queues long enough to complete a task and withdraw before a perimeter tightened. A weapon program to address this problem had to accept explicit trade-offs. It could prioritize maximum suppression over rate of fire. It could accept short effective range as a design parameter. It could accept limited standardization if the result fit clandestine logistics. The output was an unusual pistol. It was integrally suppressed. It was bolt-operated. It was built to look unremarkable when separated from its magazine. It became known as the Welrod. The device was developed within the British Covert Technical System, associated with the Inter-Services Research Bureau, and later Station 9, based near Welwyn. Major Hugh Reeves is identified in contemporaneous crediting as the inventor within that organisation. The environment was not a normal armament department. It was a compartmented design and test shop producing equipment intended for deniable issue. Station 9 used an internal naming convention that prefixed several devices with Well, and the Welrod followed that practice. The first concept followed a single mechanical decision. The action would not self-load. The firing event would occur with the mechanism locked and stationary. This removed slide impact noise at the moment of discharge. It forced the user to cycle the weapon manually after each shot. Speed was sacrificed by design. Production arrangements matched the covert requirement. Wartime Britain allocated high-grade steels, machine hours, and skilled labour to aircraft, shipbuilding, and high-volume infantry weapons. A clandestine pistol could not compete through standard channels. Manufacturing therefore used limited contracts, including production by Birmingham Small Arms and other unnamed makers. External markings were deliberately minimal. The pistol was sanitised, carrying no clear national or factory identifiers beyond serial handling needed for internal control. The weapon was built in more than one chambering. The principal service version was in 7.65mm Browning, also called .32 ACP. A later version used 9 by 19mm. The choice reflected supply and effect. .32 ACP tended to be subsonic in common loads, avoiding the ballistic crack that suppression cannot remove. 9 by 19mm was widely available and more energetic, but many loads were supersonic. The Welrod addressed this by using a ported barrel that bled propellant gas into the suppressor volume and reduced projectile velocity. The Welrod's architecture was a steel tube system, rather than a conventional pistol frame and slide. The central tube contained the barrel and suppressor components. The rear contained the bolt mechanism. At the back was a knurled knob used as a bolt handle. The bolt was operated by pull and push, with a rotation to lock. Locking used 2 lugs. The firing mechanism was striker-based with a single-stage trigger. The magazine was a key compromise. It was a single-stack detachable box magazine. It also served as the pistol's grip and was commonly covered in a rubberized or ebonite sheath. With the magazine removed, the pistol resembled a short tube, supporting concealment and deniability during movement. The design also allowed single loading with the magazine removed if required. A grip safety was the principal external safety device. It blocked the trigger unless the operator held the magazine housing correctly. This choice supported covert carriage, but it created a predictable failure mode. If the grip was not fully depressed, the trigger would not release. Gloves, cold, or an awkward posture could prevent full engagement. The magaziner's grip arrangement could also be disturbed by handling, affecting feed angle and reliability. The suppressor was integral and designed around volume and internal resistance. The barrel was short, commonly described at roughly 3.25 inches. Overall length was approximately 14.5 inches, dominated by the suppressor tube. A commonly cited weight is about 48 ounces, reflecting the mass forward of the hand. Sights were rudimentary. Some versions used luminescent markings for low-light aiming. Internally, the system used staged gas management. The barrel had multiple ports, often described as roughly 16 to 20, releasing propellant gas into an expansion area inside the tube rather than allowing it to exit as a high-pressure pulse at the muzzle. Forward of the expansion area were metal baffles and, in some configurations, rubber wipes. Baffles provided repeated changes in gas direction and increased surface area for cooling. Wipes acted as temporary gas seals. They improved suppression but degraded with use, creating a maintenance burden by design. The firing event is an explosive chain in a contained mechanism. The striker hits the primer. The primer ignites the propellant. Gas pressure accelerates the projectile down the bore. A portion of the gas is diverted through barrel ports into the surrounding chamber. Pressure falls more gradually. Remaining gas passes into the baffle and wipe section, where it is slowed and cooled further. Gas then leaves the front of the suppressor at lower pressure over a longer time interval. The result is a lower peak pressure wave at the muzzle. The quiet characteristic depends on several conditions. Projectile velocity must remain subsonic. Internal parts must remain intact and aligned. The operator must cycle the bolt with controlled movement rather than a sharp action. Environmental acoustics still matter. A shot in a corridor reflects sound. Outdoor spaces disperse it. The Welrod reduced the peak signature. It did not remove all cues associated with a lethal impact at close range. The ammunition selection was therefore part of the system. .32 ACP commonly used projectiles around 71 grains in typical loads. 9 by 19 mm loads varied widely. The Welrod's porting reduced velocity, but it also reduced energy. That created a balancing problem between quietness and terminal effect. In the Welrod's intended employment, the solution was close range and careful placement rather than volume of fire. Manufacturing introduced failure risks that were manageable only by inspection and controlled tolerances. Barrel porting required consistent hole placement to control gas bleed. Suppressor internals had to align with the bore to avoid projectile strikes. Bolt lugs and locking surfaces needed correct heat treatment and fit to maintain safe lockup. The striker channel needed smooth movement to avoid light strikes. Magazine feed lips needed consistent geometry. Any deviation could produce malfunctions that were difficult to correct quietly. The suppressor created additional maintenance requirements. Carbon fouling accumulated in the expansion area and baffles. Wipes degraded and could need replacement after limited firing. Damaged wipes could change the projectile's path and increase the risk of a baffle strike. Moisture could accumulate in the tube after movement through rain or coastal air. In cold weather, condensation could freeze and increase friction. These conditions reduced suppression performance and could affect reliability. A separate failure category came from the bolt action. The bolt had to be rotated fully into lock. Partial lock could lead to a misfire or to an unsafe condition if the cartridge case was not fully supported. A ruptured case inside an enclosed tube can vent gas rearward and deposit debris into the suppressor. Because the pistol was issued to agents with variable firearms experience, training had to emphasize bolt lock confirmation and controlled handling. Testing inside a covert program focused on process checks rather than open service trials. Sound testing was constrained by discretion. Function testing emphasized close-range accuracy, basic cycling, and suppression performance across ammunition lots. Iterations were introduced in small runs. Changes could include baffle spacing, wipe material, porting patterns, and magazine geometry. Procurement then had to track variants internally, because spares and guidance were specific to the build. Distribution imposed further constraints. The pistol's length required protective packaging to avoid damage to the suppressor tube and internals. It required magazines, and in some cases replacement suppressor components, to be supplied through clandestine routes. Airdrop containers had limited volume and competed with radios, explosives, documents, and currency. Welrod issue was therefore selective and mission-specific. Operational use is best described as controlled issue rather than mass deployment. The Welrod was used primarily by SOE, also by the American OSS, and it reached resistance elements in occupied Europe. Documented museum-held examples show resistance possession, including Danish resistance provenance, consistent with clandestine distribution. Early operational issue aligned with occupied zones where guards controlled access to rail infrastructure, depots, and administrative buildings. Units involved were small operational groups conducting infiltration and sabotage. In British terms, that included SOE agents and associated personnel assigned to covert tasks. In American terms, it included OSS elements working alongside local networks. Mission context usually involved movement to a target, avoidance of contact, and removal of a single guard if avoidance failed. Carrying method followed the construction. The magazine could be removed to reduce the appearance of a firearm. The weapon could be carried with chamber empty and bolt forward, with ammunition carried separately. Wrapping the tube reduced metal contact noise against other equipment. The suppressor length affected concealment and could snag on clothing or strike hard surfaces in confined spaces, producing audible contact that compromised the purpose of the device. Safety procedure was deliberate. Insert the magazine only when required. Confirm the bolt is closed and locked before firing. Maintain grip pressure to defeat the grip safety. Use the weapon at close range where the design assumptions hold. Cycle the bolt with controlled movement after firing. Remove the magazine for transport when feasible. Keep the suppressor front end clear of debris. These procedures reduced negligent discharge risk and reduced mechanical failure risk. Field outcomes in reporting style summaries are consistent with design limits. At very close range, the report could be reduced enough to be difficult to localize beyond immediate proximity, especially outdoors or where other noise existed. Indoors, reflections increased audibility, but the character differed from a service pistol. The mechanical click and the impact were often more prominent than the muzzle blast. The device reduced immediate alarm probability. It did not eliminate the need for rapid withdrawal and clean discipline. Failures matched predictable modes. The grip safety could remain engaged if the hold was imperfect, producing a dead trigger at the moment of use. Magazine as grip handling could disturb feeding. A bolt not fully locked could cause a misfire. Clearing a misfire required bolt movement and case ejection, introducing metal sounds. In a covert setting, that procedure itself increased detection risk. Suppressor degradation produced uneven performance. Wipes and baffles did not remain in new condition after repeated firing. As internal parts wore or fouled, suppression performance declined. This created variation between pistols and between missions. If an agent practiced extensively without replacing wipes, the weapon could be less effective when needed operationally. Clandestine supply chains did not always deliver replacement components to the point of use. The 9x19mm variant introduced further constraints. Even with porting, loudness increased if ammunition remained supersonic. The larger cartridge imposed different stresses on internal parts and on wipe durability. Reporting and later testing indicated that the .32 ACP version was regarded as quieter than the 9mm, which aligns with typical velocity behavior and gas volume. Despite limitations, the device filled a narrow capability gap. It reduced the immediate signature of a close-range sentry removal. It reduced struggle risk compared with edged weapons. It reduced immediate public reaction compared with an unsuppressed pistol. Those advantages mattered in sabotage work, where the objective was completion and disappearance rather than engagement. Impact on users appears in institutional terms. Some operators distrusted the short grip and forward weight. The handling differed from a service pistol. Commands sometimes restricted issue to personnel who demonstrated controlled use. Internal commentary also noted accidental failures to fire caused by incomplete grip safety engagement. The device therefore imposed training costs that were high relative to the small number issued. Enemy response was primarily procedural rather than device-specific. After sabotage incidents without obvious gunfire, German security forces increased redundancy, paired sentries, varied schedules, then done expanded document checks. Intelligence elements attempted to recover cartridge cases and projectiles. The Welrod's use of common ammunition reduced clear attribution, supporting deniability, but did not prevent investigation and reprisals when networks were suspected. Command-level evaluation followed clandestine procurement logic. A small tool that delivered a specific advantage could be retained even if broadly unsuitable. The Welrod was assessed in terms of task fit. When suppression and concealment were critical, it was supported. When contact was expected, other weapons were preferred. Distribution friction also mattered. A device with consumable suppressor parts required a support tail that had to be justified in procurement memoranda. As the war progressed, Britain's portfolio expanded. Integrally suppressed submachine guns offered greater fire volume with reduced sound at the cost of size. Suppressed carbines offered extreme quiet with better stability at the cost of concealment. The Welrod stayed in the category of contact range pistol, carried when concealment and a single controlled shot were the requirement. After 1945, the conditions that created the Welrod changed. Wartime workshops were reorganized, covert budgets contracted, improved suppressor design and more consistent subsonic ammunition reduced the need for a bolt-action pistol to achieve low signatures. Semi-automatic suppressed pistols could provide faster follow-up capability with acceptable noise levels. Training economics also shifted against a rare, specialized manual action sidearm. The Welrod persisted as a reference design and occasional specialist tool rather than a general issue weapon. Its total production is often cited at approximately 14,000 across wartime and post-war manufacture, with a smaller wartime subset. Its legacy is technical rather than numerical. It demonstrates a deliberate reduction of mechanical noise at the firing event, staged gas management through barrel porting, and integral suppressor volume using baffles and wipes. It also demonstrates how covert weapons can impose disproportionate support burdens through maintenance, spares, and controlled handling requirements. It remained effective when used within its narrow envelope and supported by correct ammunition, intact suppressor internals, and disciplined handling. It remained limited when field conditions, supply friction, source and operator variability collided with those assumptions. This weapon was a technical decision born from wartime pressure, effective on paper, limited in the field.